Hello, hello. Here is the video going over our transformations quiz review. So the first set of questions, you are presented with different functions and we want you to actually sketch the transformed function. So in order to do that, we first need to figure out what our parent function is. So if I look at number 1, I can see that it is an absolute value function. So I'm going to go ahead and write y equals absolute value of x, and that's my parent. That's going to help me establish 3 key points that I'm going to shift around based off of my transformations. So usually I like to start with -1, 0, and 1. And I'm going to go ahead and take the absolute value of all of these values to get my y coordinates. So absolute value of -1 is 1, absolute value of 0 is 0, and absolute value of 1 is 1. So here is my original parent function, and what we're going to do is we are going to take this graph and make adjustments to it based off of the transformations that are listed in the new function. So I can see that I have a negative in the very front of my function. That is going to create a reflection over the x-axis. So reflection over the x-axis. Any numbers that you have in front of your function, regardless of the negative, so this 3, is going to create a stretch or a compression, so a vertical stretch or compression. This one is a vertical stretch because that number is bigger than 1. So if a is bigger than 1, and a is the number in front of your function, if a is bigger than 1, that is going to be a vertical stretch. If a is in between 0 and 1, so like 1/2 or 2/3, that is going to be a vertical compression or a vertical shrink. The number inside your function, so this +1, is going to tell us how many units we move to the left or to the right. Since it is a +1, that means we are moving to the left 1. And the number on the outside of your function, so the thing that you're adding all the way at the end or subtracting, that is going to tell us how many units up or down we're moving. And since it's a plus, we are moving up 4 units. Now what I like to do is I like to create a new table of values based off of my original 3. These are my original 3 up here. And the transformations, and that's going to give us new points to graph. That's going to show us the transformed graph. So in order to do that, I do need to understand how the transformations affect specific points or specific coordinates. So when I reflect over the x-axis, so I'm going to draw a purple point. When I reflect this over the x-axis, what that does is that creates a vertical movement. Anything that's vertical is going to change or adjust your y coordinates. So I'm going to make a note that this is going to adjust my y's. A vertical stretch is also going to adjust your y's. Same thing with moving up or down. Moving to the left or to the right is going to adjust your x coordinates. So in my other table, I'm going to use this information to create a new table so I can get my transformed points. So all of my x coordinates are going to move to the left 1. So I'm going to write this as x minus 1 since I need to take those points and move them to the left. So I'm going to go ahead and take these 3 points that were up here and put them into my expression so I can get my new x coordinates. So -1 minus 1 is -2, 0 minus 1 is -1, and 1 minus 1 is 0. For my y coordinates, I have 3 things going on. I have a reflection over the x-axis, a vertical stretch of 3, and I am moving up 4. Your reflection and your vertical stretch or shrink will tell us what to multiply y by, and moving up or down will tell us what to add or subtract from y. So since my vertical stretch is 3 with the reflection, that means I'm taking my y coordinates and multiplying it by -3, as well as adding 4 since I need to move my points up 4 units. So let's go ahead and figure out what those values are. -3 times 1 plus 4 is 1. -3 times 0 plus 4 is 4. -3 times 1 plus 4 is 1 again. Okay, so let's see what these points end up looking like on the graph. So -2, 1 is over here. -1, 4, and 0, 1. And here is my transformed graph. I can see that it is now opening down. That's because of the reflection. I have moved to the left 1 and up 4. And I can also see that my points are further apart from each other vertically, because that is your vertical stretch. All right, number 2. I can see that my function is a square root function, so I'm going to write y equals square root of x. I'm going to go ahead and pick these original 3 values for my x's. Square root of -1 is an imaginary number, so for your real values it does not exist. So I'm just going to write dne. Square root of 0 is 0, and square root of 1 is 1. So here is my original parent function for the square root. Looks like a half parabola going to the right. For my transformations, I only have 2. I am moving to the right 1 because of that -1 on the inside. And I am moving down 3 because of that -3 on the outside. Okay. So moving to the right is a horizontal movement, that's going to adjust our x's, and moving down is a vertical movement, so that's going to adjust my y's. So all of my x's, I'm moving to the right 1, so I need to add 1 to them. And for my y's, I am moving down 3, so I need to subtract 3 from them. So for my x's, -1 plus 1 is 0, 0 plus 1 is 1, 1 plus 1 is 2. For my y's, well, that does not exist, it's still not going to exist over here. 0 minus 3 is -3, and 1 minus 3 is -2. So let's see where these points are. 1, -3 is right here. 2, -2 right here. And we can see that that blue graph has now shifted to the right 1 unit and down 3. This one didn't have a reflection or a stretch. Oh, gotta erase all this. There we go. Okay. So for my new function, I can see that it is an x squared, so I'm going to write y equals x squared as my parent function on the side. I'm going to go ahead and set up my original 3 points. So -1 squared is 1, 0 squared is 0, 1 squared is also 1. Your square root function, your quadratic function and your absolute value function actually do give you the same 3 points to start off with. It's just that your absolute value is a V-shaped graph and your quadratic is a U-shaped graph. Okay, for my transformations, I can see I have a negative in the front. That is going to be my reflection over the x-axis. That 1/2 is going to be a vertical shrink or a vertical compression. And I don't have anything inside my square, so I'm not moving to the left or to the right at all, but I have that +5, so that means I am moving up 5 units. Reflection and vertical shrink, that is going to affect my y's. And moving up is also going to affect my y's. All right, so nothing is happening to our x's here. So all of my x's are going to stay exactly the same. For my y's, I am multiplying by -1/2 for that reflection and the shrink, and I'm also adding 5 for that vertical shift of up 5. So -1/2 times 1 plus 5 is 4.5. -1/2 times 0 plus 5 is 5. -1/2 times 1 plus 5 is 4.5. And let's see where these points are. So -1, 4.5, 0, 5, and 1, 4.5. Now I can see that my parabola is opening down. That's because of the reflection. I can also see that those 3 points are closer together. That's my vertical shrink, and that allows the graph to end up being wider because of that vertical shrink. All right, number 4. This one is a cubic function, so my parent function is y equals x cubed. Again, starting off with these original 3. -1 cubed is -1, 0 cubed is 0, 1 cubed is 1. So these are my original 3 points for the parent. Cubic goes up to the right and down to the left. Okay, let's see what our transformations are. I have a stretch of 2, that's the number in the very front. So a vertical stretch of 2. I am moving to the left 4, that's that plus 4 on the inside, and the plus 2 on the outside means I am moving up 2. So both the stretch and moving up is going to affect my y values, and moving to the left is going to affect my x values. Do not have a reflection because there is no negative in the front. So since I am moving to the left, I'm going to take all of these x's and subtract 4. For my y's, I have a stretch of 2, which means I'm multiplying by 2 and adding 2 because I'm moving up 2. So for my x's, -1 minus 4 is -5, 0 minus 4 is -4, 1 minus 4 is -3. For my y's, 2 times -1 is -2 plus 2 is 0, 0 times 2 plus 2 is 2. 1 times 2 plus 2 is 4. All right, let's see what these points give us. So -5, 0, it's right here, -4, 2, and -3, 4. And I'm going up to the right, since I did not have a reflection, down to the left. And I can see that my graph is skinnier because my points are further apart, and that is from your stretch. I can also see that I moved to the left 4 and up 2. All right. Your next set of questions is going to be writing functions based off of transformations. So in order to do that, you need to understand what a, h, and k do to your functions. So for example, I'm going to write a f of x plus or minus h, because I can move to the left or to the right, and plus or minus k, since I can move up or down. So write the equation of a cube root function. So I've got my cube root has been reflected over the x-axis. That means I'm going to have a negative in the front of my function. Vertical stretch of 4.2 means that a is actually 4.2. Shifted 3.7 units to the left means I am adding 3.7, so that's a plus h. And 8.9 units up, that means I am adding 8.9 units on the outside, so that is a plus k. So putting all of that together, I have f of x equals negative 4.2. That's going to be your reflection with the stretch. And it's a cube root, so I'm going to do my cube root. X plus 3.7, that's going to be moving to the right, 3.7 units. And then finally plus 8.9 on the outside, and that is going to be my 8.9 units up. Using that same idea, I have a quadratic function, so that's an x squared. Vertical compression of 1/2 or 1/4 means that a is 1/4. Shifted 113 units to the right, that's going to be a minus h. And 81 units down is also a minus h. Oh no, not minus h, minus k. There we go. Don't make that mistake. So writing the function, f of x equals, no negative since there was no reflection, but I have 1/4, and then this is x squared. So x, let's see, minus 113, since I'm moving 113 units to the right, squared, minus 81, since I'm moving 81 units down. And voila, there's your equation. For your next set of questions, you are given a graph, and we need to do the same thing. So the first thing we need to identify is our parent function. So our parent function is going to be the original function before all of these transformations. So I can see from my graph that this is a V-shaped graph, which means my parent function is absolute value of x. I always like to graph my parent function when I need to write my equations because I need to see how this parent function has adjusted to get to my new purple function. Now be careful with these graphs because they are scaled by 2s, so pay attention to the way that they're scaled. I can see that there was no reflection because both my parent and the purple function are pointing up. I can see that I moved to the left 2 and down 3. To the left 2 and down 3. That's how that point has transformed to your new point. So I'm going to go ahead and make that note. Let's see, we went to the left 2 and down 3. I can also see that my points in my purple graph are further apart than they normally are in the parent function. So here's what I mean. I'm talking about these points over here. So with your parent function, they are 1 unit apart horizontally and 1 unit apart vertically. If I look at these 2 points, they're still 1 unit apart horizontally, so that means there is no horizontal stretch or compression. But if I look vertically, these are 3 units apart. So that means I have a vertical stretch of 3. So I'm going to make a note, vertical stretch of 3. So what that tells me is that my A is 3. My left 2 means I'm going to have a plus H. And my down 3 means I'm going to have a minus K. So putting that all together, I have f of x equals 3 absolute value of x plus 2, because that's a plus H, and minus 3. I'll put this in parentheses. There you go. And here's your equation. All right, let's do another one. So this one looks like half of a parabola, but it's pointing down. Anytime you see a half parabola, either opening to the left or to the right, your parent function is going to be a square root. So I'm going to write y equals square root of x. And once again, I'm going to go ahead and plot my parent just so I can see how it has changed to get to that purple graph. I can see that my purple graph is going in a different direction. So instead of going up to the right, it is going down to the right. So that means a reflection has taken place. So I'm going to make a note. It was a reflection over the x-axis. And I know it's over the x-axis because if I were to take my blue points and actually reflect them to get this yellow, I can now see that my yellow graph is looking pretty close to my purple one. So that's a reflection over the x-axis. And then I also have these shifts. So I have moved, let's see, how have I moved? I moved 2 units to the right and 3 units up. So let's make a note. So to the right 2 and up 3. And let's check our distances between the points. So I'm going to look at the reflected points because that closely matches my purple graph. So with my reflected points, horizontally is 1 unit, vertically is 1 unit. Same thing over here, horizontally 1 unit, vertically 1 unit. So we did not have a stretch or a compression. So a reflection over the x-axis means I'm going to have a negative in the front. To the right 2 is a minus h, and up 3 is a plus k. So f of x equals negative square root x minus 2 plus 3. And there we go. All right, last one. This right here is a cubic. My parent function is a cubic, and I know that because my curves are going in opposite directions. So if I draw my parent function, my original 3 points for my parent, I can see that normally I go up to the right and down to the left. If I look at my purple graph, I can see that it is going down to the right and up to the left, which means a reflection has happened. So this could, since it's a cubic, technically it could either reflect over the x-axis or over the y-axis, because either way it's going to end up giving me these yellow points over here to get my reflected graph. Oh, drawing that curve in the wrong direction. I like to stick with reflections over the x-axis if I can, but like I said, technically this could also be a reflection over the y-axis because it would give you the same thing. So I'm going to make a note. Reflection over the x-axis. And after I have that reflection, I can see that I have also moved, let's see, this point is going to become this point. So I have moved 4 units to the left and 2 units up. Let me make that note. So to the left 4 and up 2. And I also want to check to see if there was a stretch or a compression. Now I'm going to compare my yellow to my purple just because they line up nicely because of that reflection. So I can see that normally 1 unit horizontally, this is still 1 unit horizontally, so we don't have a horizontal stretch or shrink, but 1 unit vertically is no longer applied with my purple function. Instead, this unit is 2 units away. So that means I have a vertical stretch of 2. So putting all of that together, reflection over the x-axis means I have a negative in the front. Vertical stretch of 2 means I have a value of 2 for a. Left 4 means I have a plus 4 inside my function. And up 2 means I am having a plus k on the outside. This should say plus h. There we go. Okay, writing the equation. F of x equals negative 2 x plus 4 cubed plus 2. And that would give us the negative is the reflection, the 2 is the stretch, plus 4 is going to be to the left 4, and plus 2 is going to be moving up 2 units. All right, so that covers all of your questions in your quiz review. Good luck on your quiz.